Hello, and today's learning targets are I can determine the number of solutions for a system, and I can solve a system of equations by graphing. We are starting the unit on solving systems of equations. We will see two equations, and our goal will be to find the ordered pair where the lines intersect, if there is one. We will look at solving a system by graphing and then solving with algebra or algebraically, which means not with a graph, so solving mathematically. So let's take a look here at the summary of possible solutions when we're solving a system of equations. One scenario or one possible solution would be to have exactly one solution. This means if we were to graph the two lines, the two equations, they would cross one time. And so on this example here, it would be right there, and that would be one solution. So they cross one time. We could also have infinitely many solutions, and this means that both lines are actually the same line. So I know it looks like here there's one blue line, but if you think about it, the red line is the same line, you just can't see it because it's covered up. This means every point on the line, every single point that's graphed, is a solution to both of the lines because they're the same line. The last possible scenario is that we have no solution. And this means that the lines never intersect, and we know if they never intersect or never cross, that these lines are parallel. So again, you'll notice that their slopes are exactly the same. So here are the three possible scenarios that can happen with a system of equations. We could have one solution, infinitely many solutions, or no solution. Okay, now we are going to solve the following systems by graphing, and we'll tell how many solutions exist and where, if there's one solution, where that solution is. Or perhaps there might not even be a solution because it might be no solution, so we'll take a look here at a couple examples. So I see y equals 2x plus 3 and y equals negative 2x minus 5. I am first going to graph that first equation in red and the second equation in blue, so to tell the two different lines and then see where, if they do, cross it all. So I'll go ahead and graph this line and go up 3 units and plot that y-intercept, and then I'll move according to the slope, so up 2 over 1. And I'm going to put a lot of points on my graph here because I want to be as accurate as I can, because if the line does cross, I need to make sure I know where that specific point is. So I'm just going to continue figuring out, putting those lines, those dots on there, those points I should say. All right, now I'll graph y equals negative 2x minus 5. So I'll plot my y-intercept at negative 5, down 2 over 1. And I see where they cross, but I'll continue to make points on the line. And that one, let's fix that a little bit there. The one spot where they do cross would be right about here, which is negative 2, negative 1. So that's the solution. So there's one solution, and it's at negative 2, negative 1. Okay, let's take a look at the next example. Again, I'll go ahead and graph both of these equations, and I'll separate the colors. And so here, this first one, I'm going to go down 5, plot my y-intercept. Then the slope is 1, so up 1 over 1. And again, I'll try to be as accurate with my graph as I can by plotting as many points as I'm able to. So please take the time to do that as well. And I'll graph the second equation, so I'll go down 5 units as well. Down 2 over 1. And I probably don't need to make as many points now because I already can tell where they intersect. And they cross at right there at both of their y-intercepts. So this would be one solution and it would be at 0, comma, -5. Okay, and let's continue on to the next example on the next slide. Okay, let's take a look at this next example. And for this next example, it appears that both of the equations are written in standard form. And in order to graph these easier, or make it easier to graph, let's rewrite them into slope-intercept form. So I'll first rewrite this first equation. So x minus y equals 2 into slope-intercept form, which again is y equals mx plus b. I'm going to subtract x and then get negative y equals negative x plus 2. Divide everything by a -1. So y equals -1 divided by -1 is a positive 1x. And then 2 divided by a -1 or a negative is -2. So if I go ahead and graph that, my y-intercept is -2 and my slope is 1. So up 1 over 1. And again, can plot as many points as I need to get my line as accurate as possible. And now I'll rewrite the second equation into slope-intercept form because again it will be easier to graph. So I get y equals -2/3 x plus 3. So I'll go ahead and plot 3 for my y-intercept. And then down 2 units over 3, and I can already see where they cross. So I'm going to draw my other line in. And that one solution, I can even make that on my graph, is right there. And that is at 3, comma 1. So there would be one solution again here for this example, and it's at 3, 1. All right, let's continue on. Y equals 1/2 x minus 6 and x minus 2y equals 12. Let's rewrite our second equation into slope-intercept form so that we can see what both of the lines are, and then we'll graph them and see how many solutions. So here I get y equals 1/2 x minus 6. So we'll graph the first line in red, plot my y-intercept at -6, go up 1 unit over 2, get my line. Now the second equation is, and I don't know if you noticed this right away when we solve for it, but it's actually the same one. Y equals 1/2 x minus 6. So if I were to graph this, it's the same line. So you can see that, I mean, based on graphing and just based on looking at the two equations, but this would mean infinitely many solutions. And that's because it's the same line. Same line. Thanks for listening to the video. Just to recap, we graphed each equation and first had to get that equation into slope-intercept form, and then from the graph noticed if there was one solution, and we named where that point was, no solution, so if the two lines were parallel, or if there was infinitely many solutions, which means we actually had the same line listed twice. Again, thanks for listening. Have a great day. Bye-bye.